Good afternoon. My name is Dan Sokol, and I'm the Senior Project Manager here at the Boulder Ridge Project in Camas, Washington. And I wanted to take a moment today to discuss the methods and measures that we're using to reduce the transfer of sound between units and from the exteriors to the interiors of the buildings. We have a couple of systems and assemblies that we're taking advantage of to help mitigate and reduce that level of noise on the interior of the units. One of the two more important ones that we're using are STC rated windows, which are windows that were designed to be used in and around airports. So they significantly reduce the transfer of noise. They have some technology incorporated in them by varying the thicknesses of the glazing and layering them differently that have inherent principal properties for reduction of vibration, and sound is vibration essentially, right? The second most important assembly that we utilize to reduce the noise transfer between the units from one unit to the next is a type of a wall construction called a party wall, and essentially it is two separate walls. You have a 2x6 wall, a 2x6 wall. We clad both sides of them with a product called Densglass, which is essentially a modified gypsum product, much like drywall. It's just been fortified. It's much denser. It's about 3 times as dense and about 2.5 times as heavy. And then they incorporate some other materials that help give it strength and make it a little more sound deadening. So vibration has a really hard time transferring through it. There's material in it that kind of breaks that vibration up. And the most important aspect of the wall, in addition to the Densglass, and possibly more important than even the Densglass, is the gap between the two walls. It's not illustrated very well by this material. This is a material called rock wool. It's a mineral fiber product. It's more about draft stopping, and it's a fireproof product, but it only extends into the gap about 2 inches. The gap extends the entire length of the wall, and the physical principle behind that is two surfaces touching. The vibration readily transfers from one to the other, right? Because they're actually in contact with each other. You separate them, and the vibration diminishes significantly from this surface to this surface. And thereby you get a significant reduction in the sound transference, up to 70% just by creating that air gap. And the larger the gap is, the more effective it is. So you will sometimes see a townhouse project where they only have a 1-inch gap. I think that's the smallest gap allowed. And what we've done is increase that gap to 3 inches. So that separates the wall even further, which allows for a little more noise reduction. If you have any other questions, please feel free to reach out to our sales team. And I have an office on site and am available to anyone anytime. Please stop by. I look forward to seeing you out here at Boulder Ridge.